Good afternoon, everybody. This is Dr. E of the Physics Department. I'm the host of today's meeting. We have Dr. Khanna, Dr. Gaudi, Dr. Reiner, Dr. John, and we have Dr. Joe and Patrick Woodworth, and Ms. Kara Tellman, and some students join us.
Good.
So we are going to have a short meeting, and both of us will introduce ourselves quickly. And we will start from Dr. Gaudi.
Okay, I'm Dr. Gaudi, the Associate Department Chair. I've been chair on and off for many years. So at the moment, Chief's got the job. I do research in general relativity and cosmology, and I'm teaching the astronomy course.
Okay, Dr. Reiner.
Hi, Professor Joe Reiner. I've been here since 2011, and I teach a graduate level optics course and the introductory calculus-based physics courses. And I advise PhD students in research involving essentially chemical sensing and analysis.
And Dr. Deha Jong, you are mute.
Hello. So my name is Deha Zhang. So this is my second year at VCU. I teach the quantum mechanics. So I taught the quantum mechanics last semester, and this semester I teach introductory nanoscience classes. So I supervise the 2 graduate students and 4 undergraduate students. Research focuses on 3D printing.
Okay, and now Dr. Richard Zhou.
Yeah. Hi, I'm Richard Zhou. I also started last year at VCU, and one of the main focus, the growing focus in the department is the biophysics. So my research area in the biophysics and the cancer biology. So some of the project that I'm working on is how does the biophysical, like a sensing, affect the aggressiveness of tumors.
Great, and Dr. Carissa Capiano.
Hi, I'm Carissa Capuano, and I am teaching faculty in the department. I teach mostly intro-level courses of Physics 208 and the energy course. And I don't do research because I'm teaching faculty. I also help to run the Physics Tutoring Center.
Okay, the next one will be Ms. Kara Tellman.
Hi, I'm Calla Tallman. I am the academic advisor in the department. At this stage, I work with students that are second year, so sophomore on up through graduation. So your actual advisor for this year is Allison Norden, who has joined us as well.
Patrick Woodworth.
Hello, I'm Patrick Woodworth. I am a teaching faculty also. I primarily teach in the interdisciplinary science courses, but I am involved with the 207 and 208 recitations quite a bit.
Okay, Dr. Shiv Khanna, our chair of our department.
Hi, everybody. I'm Shiv Khanna. I'm the current chair of the department. I have a research group working on clusters and nanostructures. We have, I think, 2 postdocs and several students, graduate students. We also have students doing their projects during summer in my group. I teach now the nanoscience course with Deha. We are developing that course. And I teach advanced solid state and solid state physics. It's a great department. You have access to faculty members, and you can do research projects with them and talk to them. If you have questions, you can contact them and so on. So it's a very collegiate atmosphere in the department. Unfortunately, this COVID has made us link through this Zoom, but otherwise, we would have a more close party with all of you in place there. If you have any questions, well, at this point, you can email me and I'll be happy to answer anything. Welcome to the department, and we hope you succeed in the department. Dexian?
Hey, thank you. Now, probably Dr. Gaudi will introduce our department to the students. Dr. Gaudi, are you ready?
There we go. Okay. Yeah. Well, we have a department that's been here for as long as VCU has been, but not any longer. We're mostly focused in condensed matter physics and nanotechnology with a recent emphasis on biological applications. We have a graduate program in nanoscience, the Nano PhD program. That's program's been going for what, 2 years now? And it's doing pretty well. Most of our faculty members have one variety or another of research support. And if they don't, they're writing grant proposals for it right now, right? So we're a very active research-oriented department. However, we also have a lot of teaching to do. So you will find that people answer their emails for the most part, and that they will help you when you need it. And I guess that's all I want to say about the department.
Okay, our department have a really unique program we call the Nano Concentration. Dr. Reiner will introduce this program to the students. Dr. Reiner, I will make you a co-host.
Okay, sure.
Okay.
So I just have a couple slides
Yes.
to show that highlights the program. So if I can share that, and then we'll go here, and I'll do one of these moves here, and there we go. So yes. Right. So yeah, of course, welcome to the program. And I would just talk a little bit about the nanoscience concentration. So this, as Dr. Gaudi said, this started about 2 years ago. And we were thinking, when we developed this, we were thinking about how can we distinguish our department from other departments? What can we, what do we focus on? What do we do here at VCU Physics? So of course, we have a strong emphasis on teaching a broad range of topics. But we also have an emphasis on real world applications of physics. And so we have opportunities to engage in cutting edge research through nanoscience. Now, we've had a nanoscience PhD program for a number of years, but until recently, we didn't really have a similar way to outreach to the undergraduates. And so we developed this concentration to address that. So here is a little figure here, a little pie chart, getting a little bit dated, but generally still holds, which is what do people do with physics degrees? So when you graduate out of here, you'll be a physicist, but what does that mean? And so the different types of areas of employment you can go into, of course, are going to be mostly STEM based, but really the focus is on computers and applied, engineering type jobs with a strong physics background. And so we thought about that too, and we said, well, let's develop a concentration program for our undergraduates where they could maybe train or better prepare for these type of career tracks. And so that's what we've done. And so specifically, what does it mean to be nanoscience? What is nano? Well, nano is the prefix of 10 to the minus 9. So it's 0.8 zeros and then a 1 meter. So to get an idea of how small that is, if the entire Earth was 1 meter across, then 1 nanometer would be about 13 millimeters. So it gives you a sense of just how small that is, extremely small scale. But at that length scale, there are many devices and developments that need to be miniaturized and developed. And so this is going to require, applications and understanding of physical concepts. So there's a lot of applications in semiconductors, green energy, medicine, and a lot of different areas. So it's a very well-populated field. And so we in the physics department have a long history of solving these particular types of problems at this length scale, because essentially it requires a lot of quantum mechanics and understanding at that small scale. And so we have a lot of solid state physicists in this department that work on these problems. But as Dr. Gowdy said, we've also more recently been branching off into the biological areas as well. And so there's definitely an interest in the nanoscale when it comes to biology as well. And I think Dr. Joe will talk a little bit about his research, might get into some of that small scale stuff too, a little bit later on. What's the nuts and bolts of this program look like? Well, on the left side, you have generally the requirements to be a physics major. So there's about 30 credits you have to take in order to be considered a physics major. You need, I believe it's 120 total to graduate from VCU. So from that 120, 30 of them are gonna have to be these courses on the left over here. So the nanoscience concentration was designed to kind of fill an elective set of holes in your schedule. So there's a lot of room in a physics major schedule that can be filled with a lot of different courses. And so the nanoscience concentration is listed here. And so you can see the types of courses that we're focusing on helping you take are going to be focused on real world applications and development. And also they're designed to give you opportunities in research. Okay, so as an undergrad, we wanted to get people into the labs working with researchers on interesting problems, cutting edge stuff. And so as you can see, 6 credits amounts to basically 1 year's worth of research, the end of which we're hoping you can write up some report, give a presentation, and possibly lead to publication in a peer-reviewed journal. So all of these things can better prepare you and get you ready to go off into the real world through either industrial, government, or academic positions. And so that's what we're thinking. As an aside, I always put this down here as we also are interested in developing a pre-health component to our physics major. And so as you can see, there's also a path to go into the medical school and the pre-health if one was interested in that as well. But I'm not really here to talk much about that today. So, so essentially that's all I really had to say. And so, thinking of VCU physics, we focus on preparing you for meaningful jobs in STEM. We're very heavily focused on nanoscale and nanoscale research. We also have strong connections to the medical campus, but we are focused on developing you and developing a strong foundation in STEM and the physical sciences over the next 4 years. And so we look forward to working with you in that. So it's, as always, if you have any questions, you want to ask me about the nano concentration or anything else about the physics department, feel free to reach out to my email, which is listed right here in the bottom of my box. And I think that's it. That's all I had. Welcome.
Our department have many directions. For example, we just hired 2 young new faculty in last year. They do state-of-the-art research in physics. One of them is Dr. Richard Joe. So Dr. Richard Joe, would you please introduce your research project to the students?
Sure. Can you allow the screen share? That's it. So as I mentioned, there are a growing number of faculty in our department working on biological aspect. And so, yeah, since I cannot share my screen yet, I'm just gonna talk here. And so myself and Dr. Jason Reed and Dr. Lauren Pico works on the biological aspect of the system. So if you think about let's see, okay, now it works. So one of our interests is trying to understand how the DNA is wrapped around wrapped inside the cell. If you think about DNA, which is the information of everything that we are made up of, it's very long polymer. So if you stretch out DNA from one cell of our body, that will be a meters long. So that there are a lot of a sophisticated machinery to wrap these DNA around. You can think of it very long, like string. They are tightly wrapped around different proteins, and the cell developed various different machinery to control this process. So some of the interests that I have is how to understand the structure of the genome. So this genome made of DNA can have like one-dimensional structure and three-dimensional structures as well. So one of the focus is how does the one-dimensional organization, and on top of that, like folded further into three-dimensional structure, how does it impact the phenotype we observe and how does it impact the human diseases? And I also work with other like mathematical models to really demonstrate how these like genome structures actually works in our body. And one of the application is how does it regulate the cancer? How does it contribute to the tumor progression and the metastatic potential of cancer? So one of the examples here is the region called the centromere, where for historically we thought these DNA around here are basically a junk. It doesn't seem to make much substrate out of it. But recent development has shown that these DNA fragments are actually important in terms of like maintaining the integrity of the DNA. So one of my direction is really trying to understand how these so-called like a junk DNA is contributing to the tumor. And finally, I'm also generally interested in the biology and the physics of cancer. So one of the key questions that I'm asking is, how does a cell respond to other microenvironments around it? So one of the example is if you place a same cell onto soft surface or hard surface, they can turn into totally different things. So if you put a cell into a soft surface, it can turn into more like a fat cell. If you put the same cell onto very hard surface like glass, it can turn into like a bone cell. So in our department, we are trying to understand how these interaction between biophysics is contributing to the cancer biology. So if you are interested in any of these areas, feel free to write me an email, or once the things settle down, feel free to stop by my office. Thanks.
Next person will show the research in the lab is Professor Deha Zhou. I will make you the co-host first, and you can share if you have anything. Thank you, Deha. And we have Professor Bertino joining us. Professor Bertino is a director of our Nano Characterization Center. He also is the director of our PhD program in nanoscience. So he will show the students the fantastic facility we have doing nano research at the VCU.
Yes. Okay. So welcome to everybody. Sorry for being late. I had something else to attend. Okay. So what I am the director of is the nano materials characterization core facility, which is right here where I am now. I'm not in physics. I'm outside next to engineering. And we host, I don't know, $10 million, $12 million worth of equipment. And in this region, I think we are the best ones. Don't tell Virginia Tech, but we are really better than them. We have more devices, and but don't tell them, okay? So essentially, what we do, we have everything that you need for materials characterization. I will try now to walk you through the floor. It may or may not work. I also will have to wear a mask, so bear with me, okay? The quality will be what it will be. So I'm just taking now off, and I will take the laptop, rotate it, so you will not see my face, you will see the rest, and I will be talking. I hope it works. Okay. Okay, and let's see. Second, no? Okay. So, this is the entrance. Let me see. This is the sign. Okay, don't be stupid. Don't be stupid. Don't bring in any. Okay, so what we see here is the X-ray diffractometer. Let's see if you can see. Yeah, sort of. Yeah, these things are not made. At any rate, this is the X-ray diffractometer. It's about $250,000. It gives X-ray diffraction from powders. Okay. Then you see here that there are a lot of other instruments. See how big it is here. Okay, and essentially, what we host here is, for example, this one is magnetometer. This goes down to 1.5 Kelvin, and it is obtained by pumping. You take liquid helium is 4 Kelvin. To get to 1.5, you pump on liquid helium and you evaporate liquid helium. Essentially, you try to freeze liquid helium, which is impossible. But by doing that, you can go down to 1.5 Kelvin. The pain is that this thing sucks up energy like there is no tomorrow, and it's a pain to maintain. I mean, it's an excellent instrument, but man, keeping it alive is quite a challenge. This one is an X-ray photoelectron spectrometer, okay? And it tells you the chemical bond at surfaces. Okay, what is happening to the chemical bond in particles, in general in compounds. If you have C double bond, for example, or an oxidation or stuff like that, you can tell. Then here there is a state-of-the-art atomic force microscope. Here we go, and you see it is in an enclosure. The enclosure is to prevent sound from interfering, from messing with the measurement. And it is also mounted on a piezoelectric table that protects it from vibration. So you don't see much, you just see the box. Okay? Still, it works real well. Then here, what you have is a scanning electron microscope. Hang on. Hitachi with field emission cathode. Very good. Excellent tool. Costs about $750,000. No, sorry, 550. I lied. And it goes down to 2 nanometers resolution, and we use it to measure the surface of composites. Okay. And then here more instrumentation. You see again, it's quite big. And it is open to students. We train students. And then here is our latest edition. Just showing that. And this is a transmission electron microscope, which is characterized by this huge column, which is about 10 feet tall, something like that. Okay. And with this one, we go down, we can resolve rows of atoms in particles and in films. And actually, you see there, this is Carl and his. You may see on the screen there are some particles, some stuff. I don't exactly know what it is, but okay, whatever. And it is becoming very quickly a workhorse. This is an excellent instrument. UVA has one like this. Tech, no, this is better than what Tech has, I think. Or at least let me say that. Okay. We can also do chemical analysis. Okay, so in general, we welcome working with students. Like I said, we have trained students, and we also have students doing research. If typically the research of your boss needs or requires this type of instrumentation, we train students working on this. For undergraduates, of course, we have a little bit of limitations because your experience is limited, of course. So we don't allow you to work on the transmission electron microscope because that's way too much. Okay. So, but overall, it's an excellent facility, and we try to be as friendly as possible and to help people and train people as much as we can. Okay, this is in a nutshell what we are doing here. Thank you.
Thank you.
Uh,
Now,
can
education. Yes.
Can I take 1 minute?
Mhm.
Well, guys, in addition to what you've heard here, there are 2 or 3 things I want to add. First, we have other people like Jason Reed, who have very close collaboration with Medical College of Virginia, and we have a joint MD PhD program in terms of doing physics and in terms of medical thing. But more importantly for undergraduate students, and I think Ella, you might like to know that we are trying to develop a medical physics track which will prepare students for going into the medical area. Finally, I want to add something. You know, doing fundamental research is one thing, but if you go to funding agencies, or the research thing, the first question is how much we can transform the tabletop to actual industry. And VCU is one of the very few institutions which has great success in that area. Just to tell you, we collaborate between physics, chemistry, and chemical engineering in developing drugs for treating a whole variety of things at a much cheaper price. And you know, for the COVID-19, the 2 drugs, the remdesivir and another drug, which is still confidential, a $347 million from the federal government was awarded to VCU and other people. And in fact, in Petersburg, there's a new industry which is being set up to produce these 2 drugs for treating. In fact, the other drug, I was told by Frank Upton, is more promising than remdesivir. They are being produced there. So there's a whole history of transforming from tabletop research into actual industries and producing things which are relevant to the industry. They're also producing high blood pressure drugs and others. So that's something which I wanted to add, that it's quite very key. VCU, if you come here, work in the department, you'll be exposed to things which have really practical relevance. Section, you can take over now.
Okay, thank you. Education also is one of the most important component in our undergraduate program. Carissa, are you going to have something to show, or just talk about how you teach university physics to the students?
I might want to share something. I'm not sure.
Okay, I will make you to the co-host, and you can start to share.
Okay. Okay, so I'm just going to talk briefly about teaching and also about tutoring. So I'm going to discuss 2 things. So I wanted to start just by talking about how the introductory classes are taught and just give you a little bit of background on that. So one of the classes that I teach is Physics 208, which is one of our introductory classes. So when you first come in, you're going to take these foundational courses, which are going to give you your first glimpse of physics and a first sort of brush over. And so these classes cover a lot of material because we're trying to give you a foundation in a lot of things. So you have Physics 207 and Physics 208, which are University Physics 1 and 2, and then Physics 320, which is modern physics. And those are kind of going to be your foundational courses that you take in your first 1 to 2 years, depending on where you get started. And so because these classes are such foundational courses, they are courses that are useful to several different majors. And that means that we end up with class sizes that are large. And so ideally we would have, tiny classes where we had, 15 or 20 students, but, reality dictates that courses like Physics 207, 208, you typically are more in a class of 150 or 200 people. So, one of the things that I just wanted to sort of touch on with that is, I know from my perspective, and I'm sure the other professors who teach the intro courses would agree, that if you're a physics major, I'd like you to tell me, you know, come up and let me know, introduce yourself. Because if you are a physics major, that means you're going to be spending time around us and in the department. And the time will come when you get to your upper level classes that you'll be spending most of your time in the physics department. But of course, in your first couple of years, you have a lot of general education stuff to get out of the way, and you'll be doing a lot of different things. But we would like to get to know you as early as possible to bring you in and to get you involved in the department in any ways that might work, because we want to make sure that you are well supported. And we are all here to make sure that you get the best education you can, get any research experience that can be offered. And so I just wanted to kind of mention that. But the thing about these intro courses is they're providing the foundation that you're going to be using for your upper level classes. So for example, if you take a class like Physics 207, you're going to be talking about mechanics and you'll be talking about motion. And then you'll take a 300 level class that goes much further in depth than that does. In Physics 208, you'll talk about electricity and magnetism. And then later on, you'll take an upper level course that is focused entirely on it and goes far in depth, much beyond what can be done in an intro course. And so you'll have that opportunity to be learning more in depth. And so it's very important that you get a nice solid foundation. And one of the issues with having a class that's large is that it can feel like you get lost, and it can feel like, you know, you kind of slip in and out. And so if you let us know, we'll keep an eye on you. And also we're always here to help. And so one of the most important things, especially when you're just starting out, is to make sure that you get help early and get help often. There are several different ways, resources that are available to you. The first one is obviously your professor. Your professor has office hours. If you're stuck on something, a concept or something like that, take advantage of the office hours, talk to your professor, and get help as early as possible. Because of course, when you're in a class, it can become very easy to become focused on your grades and getting through and surviving and just, you know, making it through. But when you're taking courses in your major, you can't be focused on that, because you have to make sure that you're actually understanding the material and actually making the progress there, so that you're really learning physics. And so in classes like 207, 208, the large class size means that we're limited in what we can do in the lecture, but we have recitation sections that are available that you register for when you're in the class. And the recitation sections are really a good place for you to learn your problem solving skills. So there's two main emphases on that. One is that it gives you an opportunity to practice problem solving in a small group environment where you can get help quickly. And the other is it lets you work with your fellow students. One of the best ways to learn something, and especially physics, is by helping other people. So if you're working with your classmates and talking to them about the issues you're having with the homework, the struggles you're having, and listening to theirs, and you guys can help each other, you're both going to be learning from that experience. And so that's why it's so important to do it. Now, with us having to be online because of COVID, everything is obviously very weird this semester. Hopefully we'll be back on campus and back to normal as quickly as possible. But it does make, the onlineness does make it seem a little bit distant. And so, but just make sure that that you reach out and that you take advantage of the resources that are available. So that kind of will let me transition into the other topic that I wanted to discuss, which is the Physics Tutoring Center. So we started this about a year and a half ago, where we set up tutoring that is done by our upperclassmen. So the students that have completed at least our first 300 level course are eligible to apply to be tutors. We have a couple of grad students that work with us, and we provide tutoring for all students who are taking our courses. Now, what happens is we tend to get a lot of people who are not physics majors coming and getting help because, they obviously are the ones who are struggling the most. But we want to see from our physics majors as well. And so this is an opportunity. I keep repeating myself, but it really is, when you're in these intro courses, this is the time to get things sorted out. This is the time to get used to the resources that are available, to get help, and to make sure that you're understanding the foundational concepts, so that when you get to the upper level classes and things get a little more in depth, you are not having to go back and relearn things that you may have missed in the earlier class. And so the tutoring is available for all of the classes we teach. And so as soon as you need help, you can make use of it. Ordinarily, we have appointment and drop-in tutoring at a specific location on campus, but now everything is being done remotely. And so this semester, we're emphasizing the intro courses, and we're going to be having drop-in tutoring sessions where you don't have to make any appointments. But in the future, hopefully, maybe in spring, but certainly by next year at this time, we'll have our full services available. Your professors will be able to provide you with information so you can ask them if you have questions about it. If you're in one of the intro courses this year, then as soon as everything becomes available, we'll let you know. Right now, because of the transitions that are being made, we're not currently open, but we're in the process of getting open, and we hope to be in the next couple of weeks. So we will have our services available. You can get help, again, like I said, for any course, even the upper level classes, we have people. And the benefit of this is that unlike the other tutoring resources, because the university does have supplemental instruction and the campus learning center, which are available to you and you pay for as part of your fees. So by all means, take advantage of that. One of the benefits of the physics tutoring center is that the people who work with us are physics majors who have all taken upper level physics classes. And so if you're in physics 207 or 208, you're going to be talking to someone who not only most likely did 207, 208 at this school, may have even had the same professor that you had, but someone who's taken the more advanced version of it. And so they have a little more depth of knowledge and they'll be able to help you really get those concepts. And so let me just quickly see if I can share my screen, because I just wanted to show really quick. This is the physics department's website. So you go to physics.vcu.edu, and there's a link over here on the side to physics tutoring. Now, again, because we're not open yet, when you come to this page, there's not a whole lot here. But once we are open, if there's appointment tutoring available or a drop-in schedule, it will all be at this location. There's also this email address, physicstutor@vcu.edu. That is an email address that will give you the ability to contact us if you have any questions at all. I am the one who answers that email, so if you have questions, then send it to there and I'll be happy to help you out. Let me get out of this. And the one last thing I wanted to mention, and this is if you're just starting, not something that you'll be going through this year unless you're a transfer student, but if you are interested in tutoring, like I mentioned, we do hire from our physics majors. And so in the future, if tutoring is something you think you might want to do, you can also, make a little money on the side, because we do pay our tutors. And you can become a tutor and help your fellow physics majors. But I think that that's all I had. I just one last time to say that, especially in the intro courses, if you feel yourself feeling overwhelmed, if you feel like you're getting lost, get help from the tutors, ask lots of questions in your recitation, talk to your lecture professor. We all want to help you and we want to make sure that you guys get this solid foundation. So we're here to teach you. That's our job. And so please take advantage of us. Let us help you learn physics. So thank you.
After you take 200 level classes, introductory physics, you are going to have one step up to taking 300 and 400 physics. I'm teaching one of them in a 300 level. What I'm teaching is in a small classroom with about 20 students joining in a classroom. The way I'm teaching it is completely different from how the large class is taught at the VCU. I manage students into small groups in my classroom, 5 students in a group, each one assigned a role in the day when they come to the classroom. I assign them small project related to the material I introduce in the classroom. They work on that small project all together within their own group and try to solve the problem. Each students in a group take a different role to work out the project. For example, one day, student A is assigned as a manager of the group. So the manager will take care of everybody during the day to make sure everybody work on the project on time and reach the same answer to the question. And some other roles, like a student's role, quality controller, and some other roles are assigned to the individual students. The idea is learning physics is to think through it, work on something can test your understanding, and you may be able to learn better in that way. I also assign students, individual students, work on one complicated physics problem using computer. For example, using computer to do simulation, using computer to do the calculation. It's not only just a pencil, paper, that kind of work. The idea is, today, a lot of physics study is based on computer programming. If you learn at the early stage in your study in physics, you probably have a better idea if you move on to the graduate level to study physics using computer or based on modeling. Another purpose of this assignment is maybe you are going to, in an industry job, require you apply computer and physics skills to finish a project, or even just create a program to do something. So that is how I teach small classroom, higher level physics. If you go to that class, you will see more details about how I teach in those classes. And this is a really brief introduction of how I teach small class, higher level physics. The last few minutes, I would like to ask Kayla to talk about the counseling service in physics department. And after that, if you have questions, we will stay around to answer your question. Kayla, are you ready?
Yes, yes. Hi, everyone. Like I said, my name is Calla Tallman. I am the academic advisor. I will start working with students from their second year or sophomore year up through your graduation. For your first year, you work with Allison Norden. She's fantastic. And we communicate and work together, throughout your first year to make sure that you assimilate into the department really nicely when you move on into your second year. With that, my role as your advisor is to help you navigate your time at VCU. And that can be everything from managing mental health, personal things, connecting you with resources on campus to help with that, to obviously academic related things, connecting you with resources to help you with academic issues, the good and the bad. I'm a support system for all of that. I've been in academic advising for 7 years now. And what I have been telling my students for those 7 years is it's your job to be a successful student. It's my job to help you and to facilitate that process. So I don't expect you to understand the bulletin in detail. That's my job. But I'm here to help you understand what's in the bulletin that is applicable to your degree. I don't expect you to understand degree works in its entirety, but that's the official audit of your degree. So I'm going to teach you how to read that every single time you come to my office. We'll have that up on the screen. In a normal non-pandemic time of the year, academic year, we do have some required advising. Students that are in Physics 301, I like to meet with you because that's a great midpoint. You're close enough potentially to graduation that we want to start talking about the next few semesters to make sure that you're not missing any free electives and upper electives. We want to talk about, do you need to get some research under your belt? What are your goals post-graduation, and how can we enhance your resume and your experiences at the undergraduate level to propel you forward. So that's when we do that. And then if you're ever on morning on probation, which I don't think anyone will be, but I do require those students to come meet with me as well to ensure that we're getting you back into a good place and on good standing. Of course, this year we will be virtual. I'll be virtually advising through the end of this calendar year. And then I will go on maternity leave in early January. And I will return in April, thereabout whenever this baby arrives. But so who knows what the spring will look like in terms of in-person or virtual. But at least through the end of this calendar year, we will be virtual advising. So we won't be doing required advising this year. But by the time you move on into your sophomore year, hopefully we'll be back in person and we'll start all of that up in the fall. But yes, that's pretty much what I'm here for. You know, I love working with you all. I like to hear the good news that you got an A on this exam that you didn't think you would get an A on, that you got to do research with a professor that you've been really wanting to get into their lab. Big and small, I'm here to support you through everything. And that's all I have.
Okay, thank you.